Hey there, Algebra 1 students. Today I wanted to talk to you about parabolas. We've been talking about quadratic equations for a while, but you may not realize that they are quadratic equations or functions. The parent function for a quadratic function is f of x equals x squared. So anytime you see a graph or an equation that has a degree of 2 or x squared term in it and no higher powers, that's a quadratic function, and its graph will look like a parabola. It's sort of a U-shaped graph called a parabola. And parabolas are symmetric, right? They have an axis of symmetry, so that you could mirror it over that axis of symmetry and it would land on itself. It also has a vertex. In this case, it's the lowest point. Sometimes it is a maximum or the highest point, which is your vertex. It is decreasing from negative infinity to 0. It is decreasing here, and it is increasing from 0 to infinity. And when I say it's from negative infinity, I'm talking about the x values. If we extended the x values all the way out to negative infinity, this would be really, really tall because negative infinity times negative infinity is a really big number, right? But as you get closer to the 0, it is decreasing. It is decreasing, going down from left to right. Whereas at 0, 0, it starts to increase and it goes up from left to right. When we're considering whether something is decreasing or increasing, we are always considering from left to right. What is the graph doing? This is your parent function, f of x equals x squared. We need to be able to compare different quadratics to this parent function, f of x equals x squared. So let's do that. Let's look at a couple examples. When you multiply x squared by 5 and get the equation 5x squared, g of x equals 5x squared, and I ask you to graph it, you should know that it's going to be a parabola because of the x squared term, right? You can still plot some points though, right? So we can consider what happens to certain x values. If I plugged in -1 into this equation, 5 times -1 squared, we square the -1 first, right? And that's just 1, and then times 5 is 5. If we plugged in 0, we would get 0, and if we plugged in 1, we would get 5. And so I plot these points, right? I plot the -1, 5, the 0, 0, and the 1, 5, and I try to connect them with a smooth curve, okay? Now, when you are doing your homework, they will probably ask you to compare this graph to the graph of f of x equals x squared. So I have plotted in red the graph of f of x equals x squared, but I didn't explain how we get there. So let me do that real quick. If I did -2, -1, 0, 1, and 2, when I square the -2, I would get 4. When I square -1, I get 1. At 0, it's 0. At 1, it's 1. And at 2, it's at 4. And so I plot those points, and that's how I get the graph of y equals x squared, right? So how does the 5x squared equal to, compare to the graph of x squared? Notice it's skinnier, right? But in math terms, we don't say, oh, it's just skinnier, right? We would say that it's either a vertical stretch or a horizontal shrink. This is a vertical stretch, right? So g of x is a vertical stretch of f of x by a factor of 5 because of the 5 right there. All right. Let's try another one. let's say you've got g of x equals negative 1/2 x squared. So I plotted some points. I plotted more than I did last time to give you a better picture. If I evaluate this function, right, at -2, I get -2. When I plug in -1, I get negative 1/2. When I plug in zeros, I get 0. When I plug in 1, I get negative 1/2. And when I plug in 2, I get -2. You have to be very, very careful when evaluating these functions, right? If you are squaring a negative number, you end up with a positive number. But if you have a negative in front, that will make it negative. So this negative here should tell us, well, let's consider the x squared tells us it's a parabola. The negative in front means it opens down, right? Positive opens up, negative it opens down. I would be showing you dance moves right now if I could. Maybe soon. Not today though. So the negative 1/2 means it opens down. And so I plot these points, right? -2, -2, -1, 1/2, 0, 0, 1, negative 1/2, and then 2, -2. And I connect those with a smooth curve. And then I also graph the y equals x squared with the same points that I had previously, right? And then I ask myself, right, how does this compare to this, right? You can see it's flipped over the x-axis and it's fatter. But when we are talking about parabolas, we don't say, oh, it's fatter, right? We would call this a vertical shrink with a reflection in the x-axis. A vertical shrink with a reflection in the x-axis. I hope that this helps you as you are graphing your parabolas. I hope you are well. We'll see you next time.